Hello everyone. Welcome to another webinar organized by Rangle. In today's webinar, we'll giving you an introduction and overview of the newly released Angular DevTools. My name is Sumit. I'm a solutions architect at Rangle, and today we have Minko with us.
Hi everyone, my name is Minko Gechev. I'm leading the Angular developer relations team at Google.
Okay. Thanks, Minko. So let's get started. We have already done our introductions. Next, I'll tell you about some of the history and background of the DevTools, then explaining some of the features of the DevTools, then giving you insights into how you can improve the performance of your application using DevTools. In the end, we'll take some questions. So let's get started. Now, since 2015, Wrangle has been working with Google on the tools and resources for developers, including our Angular training guide, which we recently updated and released. In partnership, we introduced Augury at ngconf, which became the most used tool for debugging and inspecting Angular applications using Google Chrome. It was an excellent tool for Angular developers, new and experienced both. Continuing on the work, a new version of Augury, now called Angular DevTools, were released at Google I/O this year. We always had a vision of what DevTools for Angular could be. So we worked with Angular team to rework Augury from the ground up, including the most requested features by the Angular developers. Angular DevTools is a Chrome extension that provides debugging and profiling capabilities for Angular applications. It allows developers to visualize their code, helping them understand what Angular is doing under the hood. DevTools allows developers to preview the structure of their application, providing insights into the application using the new debugging APIs provided by the Angular framework itself. Another prominent feature that is different from Augury is the ability to profile your Angular application. With new dev tools, you can debug the performance of your application quickly. DevTools will display all the change reaction cycles happening within your application. It can also present data in various formats. And as developers, you can quickly drill down and improve the performance of your applications as needed. Now I will show you how the Component Explorer looks like, giving more details about it, and then we'll provide a live demo of how it works. Over here, you see the left-hand section of the Component Explorer. This lets you explore the structure of your application. In Component Explorer, you can explore the structure of your application using the component tree, as it displays the hierarchical relationship between the components and directives within your application. You can also visualize and inspect components and directives. Search for specific components of directive by name using the search box above the tree if you have a large application. As a shortcut in the console, Angular DevTools also provide you with access to instances of the recently chosen components or directives. Now, similar to Chrome DevTools, you can also inspect the page by selecting a particular component using the inspect element icon. In the previous screenshot of the Component Explorer, you can click on any of the components in the component tree and select it. Once you have selected the component, you will be able to view the metadata and properties, inputs and outputs of that particular component. Like Chrome DevTools, the properties view allows you to edit and update the value of any input or property if they are editable. You can also navigate to the host element of a particular component or directive by double clicking in the Component Explorer. For components, Angular DevTools also allows you to navigate to the source of that particular component using the view source icon in the properties view. So let's see everything in action. So I already have an Angular application running, which is basically a to-do application. Now, first thing you will notice if you load your Angular application is the DevTools icon on the top right. Now, if you open any of the Angular app, by default, the icon is black in color. But as soon as you open any of the Angular application, it turns red, telling you that that you have opened the Angular application. If application is running in dev mode, will show the icon saying application is running in dev mode, and you can go and start inspecting your application. Now let me open the DevTools. So if you have Angular DevTools installed on your on your Chrome, you will see a new tab called Angular in there. Now clicking on that will load the Angular DevTools for your application. The first thing you will notice is basically the component tree of your whole application. Now, as mentioned, you can always search for a particular component and hit hitting enter and keep navigating, and it will keep on circling if you keep on pressing the enter. You can always select a component by clicking of any of those elements in there. Now clicking off on any of the particular element, as I mentioned, will show you the properties of that particular component in the properties view. You can view the details of any of the particular element in here, and you can always go and add it. So if I want to change the label of this first to do, you can go and double click on the element and then change. Like if I say I want to buy some stickers and just hit enter, and it will change the value in the UI itself. You can always also change booleans or any other variable. So I will change it to true, saying it's done, and hit enter, and you can see the UI gets updated instantly. The view source, so this is the view source icon that I was talking about. You can always click on that, and it will take you the source. If you have source of that particular component in the source explorer of the DevTools of the Chrome DevTools. Now double clicking on any of these components will take you directly to the elements tab in the Chrome DevTools. So I will double click on app to dos, and you can see it directly taken me to the HTML tree of that particular component. One of the other two features that are there, you can also, we have the dark mode enabled. You can always enable that, and if you are looping and you have a lot of loops in here, you can always show the command nodes by enabling the command nodes over here. One last feature that I was talking about in the console is basically going to the console and writing $ng0. It will show you the component that you have recently selected, and going in the similar fashion, ng1 will be the previous component that you selected, ng2 would be the previous one that you have selected. And you also have the Angular version that the application is running on that. Yeah, that was it from my side. Now Minko will go and explain the profiler for you. Over to you, Minko.
All right. So in this part of the presentation here of the webinar, I'm going to show you what the Angular DevTools profiler is, how you can use it, and what are the common categories of issues that you can face and how you can resolve them. So let me start with a very quick live demo. As Sumit already shown you, you can use the Angular tab in Chrome DevTools in order to open Angular DevTools. The profiler tab has a record button. So when you click on this record button, DevTools is going to start recording change detection events. Each time when you interact with the application, Angular DevTools is going to capture all different change detection cycles in real time that Angular performs in order to synchronize the view model with the view. So you can see that by expanding the navigation bar here on Angular.io, we triggered 15 change detection cycles. If we continue navigating, we're going to continue triggering change detection cycles. And as you can see, the different bars have different height. The larger a given bar is, this means that we spent more time in this change detection cycle. So for example, if we want to inspect this change detection cycle right here, we're going to see that we have spent about 21.3 milliseconds, and we reduced the frame rate from 60 to 30 frames per second. Also, we can see what was the trigger of this change detection cycle here, which was an XML HTTP request load event. At the bottom, below the timeline, the change detection timeline, we can preview the individual components, and we can see how much time we spent in each one of them. Here we have our bar chart view, which shows the components one after another based on the components we spend the most time in it first. If we click, for example, on the navigation item component, we can see that we spent quite some time here in the ng on changes lifecycle hook, and we spent a little time in change detection. There are different views that you can use to preview the time distribution in each change detection frame as well. For example, a popular view is the flame graph view, which allows to preview a more hierarchical structure of the entire component tree. So let's say we want to expand what is happening in the mat side nav container. We can see that we have an ng4 here. We can go back, and let's say here we can preview what is happening in the doc viewer component, and we can see that in the announcement component we spent about 1.4 milliseconds in changes. The third view actually that we offer here is the tree map view, which is a more obvious way to stress on the components where you spend the most time in. So here the CDK scrollable view, for example, we spent quite some time in it, about 18 milliseconds, which is considered a lot given the budget that we have of about 16 milliseconds in order to make sure we're not dropping frames. Another functionality that the profiler offers, specifically in the flame graph view, is showing only the components where we performed change detection. This is particularly useful when we want to debug the on-push change detection strategy. In this case, we can see where the intuitive behavior that we have in mind when we configured our change detection strategy is actually not applied in practice. So this has been quite useful to teams that we have been working with in order to understand what is actually happening in their applications. I think these are the main features that we can cover today. There is an additional feature which allows you to better integrate Angular DevTools profiler with Chrome DevTools by enabling the timing API. This functionality allows you to profile the application within Angular and Chrome DevTools, and allows you to preview individual Angular change detection events within the Chrome DevTools performance timeline. So this is something that I'll recommend you just to have a look at. All right, so let us discuss how we can use these insights to actually identify performance challenges in our applications and how we can improve them. So the top performance pitfalls that we have discovered so far are performing unnecessary change detection cycles, slow computations in our application that are causing frame drops, and having large component trees. These are the three main patterns, and let me show you how you can identify them by using the tooling that we just looked at. So first, unnecessary change detection cycles. Usually when you have many redundant cycles, your timeline is going to look something like this here. Pretty much you're going to notice that you have a lot of change detection events, and there is usually a common source, which most frequently is either request animation frame or set timeout. Usually when people face this issue, it is mostly due to triggers by third-party libraries. So let's say you're using a library that that is rendering stuff on an iframe, and it is performing this rendering on every animation frame so that it can re-render the entire canvas. And if this is the case, you're going to see many change detection triggers, and you'd have to eventually initialize the library outside of the Angular zone so that Angular doesn't monkey patch request animation frame for this particular use case, and you can have fewer change detection cycles. So this is the usual cause of this problem, just like third-party libraries and the scheduling performed within them. And the way to fix this issue is to just run the initialization logic outside of the Angular zone. Another performance challenge, which is also pretty easy to identify with Angular DevTools, is slow computations. Usually when you have slow computations, you just see that you're spending quite some time in a single change detection frame, and there is one of your components that is taking the majority of this time. In this case here, for example, we can see that we have spent over 40 milliseconds in change detection in this particular change detection frame, and we have spent over 30 milliseconds only in the home component in performing change detection. This means that you have an expensive binding somewhere, and this expensive binding is somewhere within your template. So you can either just look at your source code and guess where this binding is, or you can comment different pieces of your template so that you can isolate exactly the binding that the slow computation is associated with. This is a relatively easy to fix challenge by using memoization or pure pipes. So if you're using pure pipes, you can encapsulate the slow computation within a pure pipe, and this time by using pure pipe, Angular would not have to recalculate the value every time when it runs change detection, unless you change the inputs of the pure pipe. Another alternative is to use memoization by using the memo decorator that is available on npm, or ideally, optimize the associated algorithm that is causing the slowdown. This is the most optimal solution that I would recommend you to use. However, some cases, just the algorithm is complicated and you may need to run it off the main thread into a web worker. This is eventually another workaround of this problem. And the final challenge that we're going to look at is large component trees. This is probably the least trivial issue to resolve. When you're facing this difficulty, you usually have many different components, hundreds or even thousands of components that are rendered onto the screen, and each component's change detection is taking only a fraction of milliseconds. There is nothing much you can do in order to optimize the change detection for a particular component, and the challenge is coming from all these different components coming together and Angular having to render them or perform change detection for them. So let me make a very quick recap of how Angular's change detection works so that I can give you an intuition on how you can mitigate your risks of dropping frame when you're in this situation. Here we have a parent component and a bunch of child components. How Angular is going to perform change detection is first to run it in the parent component, and right after that, it is going to go in depth in each child and check for changes. It is interesting, though, how the framework behaves depending on the change detection strategy that we're using. If we're using on-push, detecting for changes is going to be mostly simple and mostly cheap, because the framework is going to perform change detection only in the components which have new inputs based on triple or based on double equality check. So based on reference check in this case. However, if we're using the default change detection strategy, Angular is not going to skip any of the children components. It is going to invoke the change detection function that we have generated as part of the Ivy code for each individual child component, which means that Angular will have to go through all the different bindings that you have within your template. So my recommendation in this case would be to do a slight refactoring in your component tree. You can introduce eventually a new parent component, and under this component, you can move all the different child components that needs to use the default change detection strategy. So in this case, if Angular runs change detection, it is going to skip this entire left subtree, and it wouldn't run change detection within it unless the parent component has received new inputs. So this is clearly one of the solutions that can make your application faster, just using on-push change detection strategy. Another way, though, is going to be to just make your component tree smaller. And there are a few different ways to do that. And this is actually going to be my ultimate recommendation, because even if you optimize your change detection strategy and the way Angular performs it, the framework would still have to render all these thousands of components for the first time on the screen when the user opens the application. And this is going to cause frame drops by its own. So my recommendation when you have to deal with thousands of components would be to use, let's say, virtual scrolling. If you have a list, use pagination, or even implement a more smart rendering strategy by rendering components on demand, only when they're visible within the viewport. All right, that was pretty much everything I wanted to share about the profiler. Now, Sumit and I would love to take your questions and discuss more profiling, debugging, and Angular. You can, I guess, ask your questions directly around where you're watching the live stream.
Um, um, yeah, I'm just checking. So one of the questions that we had is, Minko, can we use Angular DevTools rather than the Chrome DevTools?
Sure, yeah. Pretty much Chrome DevTools is a very powerful tool that provides you a lot of insights into the execution of your application. It will let you inspect the individual functions invoked within the application. So this is super powerful, and at the same time, it could be a little bit noisy. So if you're dealing with an Angular application, you may see not only the function invocations within your application, but you're also going to see all the invocations within the Angular framework. And this may make things extra complicated to identify where the challenge just in your applications are coming from. So Angular DevTools provides an Angular-specific view to the life cycle of your application, which hopefully makes things easier to understand and to profile.
Thank you. I think there was one more about asking about what is the minimum required version for Angular for DevTools support. And as far as I remember, it's Angular version 12 with Ivy, right?
Oh, actually,
Uh,
it supports Angular version 9.
or 9 with Ivy enabled. Sorry.
Yeah,
Yeah.
you're right about version 12 that we have better support for Angular version 12 because we introduced debugging APIs that allow us to better inspect the component tree. And also we have more stable profiler APIs that let us plug into the very much like deep into the lifecycle of people's applications. So we can detect slower output execution, lifecycle hooks, and change detection. Where in older versions of Angular, we cannot, for example, measure how long did it take for a particular output to get executed. So we would recommend Angular version 12 plus, but version 9 would work as well.
I don't see any other questions. I think probably that's it. Thanks everyone for tuning in. Well, we'll see you, hope, in the next one. See you. Bye bye.